Okay, so we are ready to dive into the core of statistics. Statistics are a collection, an analysis, and the interpretation, and even the presentation of numeric data. We use statistics in order to assess and understand the variables that we are interested in comparing. We could use statistics to see what is the rate of depression in the population. We might use statistics to compare different groups of people to each other. We use statistics really for anything that we're going to need to have a quantifiable understanding of. So let's go into some of the specific aspects and parts of a statistical analysis. Anytime we're going to ask a question about a population, and the population is really the group of people that we're trying to study, we have to understand that it's quite difficult to measure the information of an entire population. We're not going to be able to give a test to every single person or a survey to every single person. So therefore, we pick out samples of a population. A sample is a representative subset of the larger population. So perhaps if I'm interested in understanding the fashion trends that are occurring in the population, I might look towards a college campus to give me a sample of the broader population. I might even go further within a college population to assess just those students who are living in state versus people who come from out of state. So each subset of my broader population gives me a sample for me to assess. Ideally, when I'm utilizing a sample, I'm going to do so in a random way so that I'm not going to create a bias by how I select the people that I want to measure. So just by brief example, if I want to know what the intelligence level, average intelligence level of a college is. So I teach at a college called Baruch College in New York City. And if I wanted to know the intelligence level of the Baruch College student, if I went out to take a sample of all of the students in my class, I teach a class of 400 students at times. So if I only look at the people in the front row, and I ask everybody in the front row for their GPA, I'm likely going to get a high GPA average from those in the front row because it's a biased sample. Most students who are achieving or are high achievers will sit in the first few rows of a college course, and therefore the GPAs will be higher. It's not a representative sample. For me to do so, I would have to get a random sample of, so if this is my classroom, not just the front row, but I'm going to have to get a student from here and there and there and all over the classroom, sitting in the back in the middle, and that would be a more representative sample of my population. Once I'm getting my sample, I want to also create norms, which are my ability to identify the normal behavior of a group in order to make comparisons to that group. So if I, let's say, want to understand intelligence, again, I want to get a norm from the broader sampling of the population. Okay? I'm going to want to see what is the average intelligence level of people ages 18 to 35. And once I establish my norm, it helps me make comparisons for the larger group. Okay. Now, within statistics, I'm going to want to be able to describe my numbers, describe my data, and we do so using descriptive statistics. And these statistics descriptors are used mostly for correlational and experimental designs, which are really the most popular and broadly used research designs. And they help me provide a measurement of the behavior from a sample. So there are three particular descriptive measurements that we use, or descriptive statistics that we use. The first is the mean. The mean is simply the average of a group. So if I have 5 scores, then I take the average of the 5 scores, and divide it by 5, or I take the total of the 5 scores and I divide it by 5. So if I have 10, 15, 10, 15, and 10 as my 5 scores, I have 30 and 30, I have 60, divide by 5, right? And that is going to come up to 12 is my mean score, right? Then I have the mode. The mode is the most commonly occurring score. Which score among all those that I have repeats the most? And in this case here, with my numbers, I have 10. Okay, 10 is the mode in this particular statistical data set. Finally, I might want to know the median score. The median is the middle score. As if I line up all of my scores from lowest to highest, so in this case it would be 10, 10, 10, 15, and 15, and the median or middle score in this case is a 10. Okay, so that is the middle score, which divides the lower and upper halves of all of my scores. Okay, let's move on to talk about the standard deviation. The standard deviation is a statistical measure of how much any particular score in a sample varies or moves away around from the mean. So if I have an intelligence, again, we're using intelligence a lot here, but let's say it's weight. So if I'm going to look at the average weight in a college population, this is going to be my distribution curve. Over here is going to be my average score. This is average right here in the middle. Let's say it's 100. Let's use intelligence to make it easy. So 100 would be my average or mean intelligence. And I have one standard deviation away at 110, and then at 90 is one standard deviation away. I know it's a very fine print over there, but one standard deviation away from 100 is 90, and that is my measure of how much I vary from around the mean. The higher a standard deviation, the more variability or the more spread there is. The lower the standard deviation, the less spread I have. So if I only have one standard deviation away from the average IQ score, it's 10 points of intelligence, give or take one direction or the other. If I have 3 standard deviations away from my average 100 intelligence score, that's going to take me way further out, maybe even as high as 145 IQ score, and maybe as low as 40 or 55. Okay, so 55 intelligence score or 145 is quite spread away from the mean. And also we have, represented by this image here that I drew out for you, is the normal distribution. A normal distribution is a bell curve shown above, which shows a symmetrical alignment of the variables. Again, here it might be intelligence. So that in the middle is the average. I have the most amount of people are going to be represented in this domain. And then on the edges here, I have fewer people that are going to be in the extreme 160 IQ score, and there's fewer people that will be in the lower range of 35 or 40 in IQ. So this is referred to as a normal distribution, rather than, let's say, it being weighted like this. That would be a non-distributed statistical data set. Okay, let's move on to the last point here, and that is to talk about inferential statistics. Inferential statistics allow us to make inferences about populations based on characteristics of your sample. So to do this, researchers use tests of statistical significance. To understand what statistical significance is, we should keep in mind that any relationship, for example, in a correlational study, or any difference between two means, let's say in an experiment, could have happened by chance. Who's to say if depression scores go up when we change the clock and we have fewer daylight hours? We hear about this a lot. There seems to be a correlation, but who's to say for sure that there really is a relationship between number of daylight hours and depression scores? Maybe it happens by chance. So there really would never be a way to know unless we came up with methods of evaluating the differences. So if a relationship or a difference is statistically significant, it simply means that it wasn't likely to have happened by chance. And basically it's saying that the relationship is meaningful if there is a statistical meaningfulness between the two variables. In other words, if two variables are not correlated in a population of people, and then you draw a sample of those people for your study, the variables might still be correlated in your sample just by chance. And if it is just by chance, then your correlation coefficient in your sample should be somewhere close to 0.00 or close thereof. After all, that's a true correlation in your population. The bigger the coefficient, let's say I have a point, again we're going towards positive 1.0, so if I have a 0.89 correlation coefficient, that shows that there is quite a statistical significance to the relationship between my variables. So the information that we presented here is dense, it's complicated. Statistics is probably the hardest part of all of psychology to understand. So take your time to review the video again, to review the written materials on this topic again, and definitely take some sample questions that we have set up for you to make sure that you're understanding the material. All right? We'll see you over at the next submodule.